Our lesson for today will be looking at Chemistry 1501. The topic for today will be looking at limiting reagent, access reagent, theoretical yield, percentage yield. Lesson 104. Let us start. In this lesson video, we'll be looking at one of the questions that we have. This question was extracted from one of the assignments. It's based on multiple choice, but we will be explaining everything in detail using calculations. So looking at the question, or let me say the scenario, it says consider the information below to answer questions from 9 to 12 below. The balanced reaction, we have sodium hydroxide reacting with carbon dioxide to form sodium carbonate and wood. In the above reaction, 3 mole of sodium hydroxide and 4 moles of CO2 are allowed to react. Then the first question, which is question number 9, which reagent is the limiting reagent? So basically, I use 2 methods to determine this. For the sake of understanding, I'll be presenting 2 methods, then we'll choose which one is suitable for you. So the first method, I'm going to be using a table like this, whereby we simply have 2 columns, and then our first reactant, we put it here. Then our second reactant, we put it here. Then we need this balanced equation. So it's very important that we have a balanced equation. So the first step that we are going to do, normally we are given the mass of each reactant, and then we calculate the number of moles. But in this case, we are given the number of moles. Then we're given that the first number of mole is 3 moles. These are the moles that we have. 3 mole of sodium hydroxide and 4 mole of carbon dioxide. I repeat, normally we are given the mass, and then the first step would be to calculate the number of moles of each reactant. We need the number of moles. So allow me to label this as the first number of mole, also this one as the first number of mole, but let me use a different color for this one. So it's the first number of mole and the first number of mole for carbon dioxide. Then from here we go to the second step. The second step is to calculate the second number of mole for each reactant, and then we use what we call mole ratio. So we are going to take the number of mole of sodium hydroxide divided by the number of mole of carbon dioxide equals to, we look at the mole ratio. We have 1 here. Since you don't have any number here, you must know that it's 1. So the corresponding coefficients for sodium hydroxide, it's 2 over the coefficient of carbon dioxide, which is 1. Then from here we have number of mole of sodium hydroxide divided by, we put this number of mole here. So we have 4 equals to 2 divided by 1 is simply 2. And then from here we are going to multiply by the number causing the fraction, which is 4 in this case. So we have sodium. Let us actually multiply here. Multiplied by 4, also multiplied by 4. Then we have sodium hydroxide equals to 4 multiplied by 2, it's 8 mole. Then allow me to label this as the second number of moles for this. Then we go back and we calculate, do the very same thing with carbon dioxide. So the one that we're looking for, we normally put it on the numerator level, divide by the number of mole of the other substance that we're actually checking, equals to the corresponding, we have 1 and 2, so it's 1 over 2. Then we have CO2, we divide by this, which is 3, equals to 1 over 2. Then from here, we're going to multiply by the number causing the fraction, in this case is 3, so we multiply by 3 both sides. This will get rid of this, and then we have number of mole of carbon dioxide, it's equals to 3 over 2, which is the same as 1.5 mole. So in this case, I want us to explain this. Then this will be the second number of mole. I want us to explain this in detail. If you have watched the other lesson videos based on this, you would understand this method very well. So in this case, what do we have? We have two number of mole. The first ones are the ones that we currently have. Then the second ones, you should understand that it's a theoretical values. We are checking how many number of moles do we need. Remember that we are reacting the two, and we are saying that the limiting reagent is a substance that is used first, or it is used up completely to stop the chemical reaction. So if we react to reactants or substances, chemical reaction will occur, and then in order for the chemical reaction to stop, one of the substances will be used up completely, and then we are going to have another substance which will be left. We refer that as excess reagent. It's in excess, we have more of that substance. So limiting reagent is the substance that will be used up completely to stop the chemical reaction. So in this case, we have two number of moles. The first one, it's the number of moles that we have, and then the process that we were doing here, we were checking how many moles of this do we need to react this completely. We cannot just look at the numbers and say, since you have 3 and 4, and then 4 is the excess reagent, 3 is the limiting reagent. It doesn't work like that. We are dealing with moles, we are dealing with a small fraction of substances, so we need to perform mole ratio procedure to determine that. So we want to check how many moles do we need from this 3 mole in order to react with this completely. So looking at this, we can see that the second number of mole, we need 8 mole. But comparing the two, we don't have 8 mole, we only have 3 mole. So we don't have enough of 8 mole to react this completely. In order to react this completely, we need 8 moles of this, but we only have 3 moles. So this confirms that since we have insufficient number of moles of sodium hydroxide, our sodium hydroxide will be the limiting reagent. Or we can check with the carbon dioxide. We have 4 mole of carbon dioxide, and then we've checked how many moles do we need to react this completely, to react sodium hydroxide completely. This 3 mole of sodium hydroxide completely, we need only 1.5. Do we have more than 1.5? Yes, we do have. We actually have 4 more. So this is the excess reagent. This is the only number of moles that will react completely with this 3 mole of sodium hydroxide. So this is the first method we can use to determine the limiting reagent. So to answer this question, we can quickly go to our multiple choice. So the correct option is actually this, which is option 1. Option 1 is the limiting reagent. It's very important that you watch the previous lesson videos whereby we're dealing with this concept to understand it further. Since we are dealing with a practice question here, we do have a lesson videos, or let me say lesson videos that explain this in detail. So for the second method, it's more or less the same as the first one. So we have 4 mole of this, then we have 3 mole of this, or actually made a vice versa. We have 3 mole of this, then we have 4 mole of this. So our next step, we are going to write number of moles of sodium hydroxide, number of moles of carbon dioxide. So basically we are going to test each. So if we start with sodium hydroxide, we want to check whether sodium hydroxide is the limiting reagent. We are going to put X here. And then we are going to take the number of moles of carbon dioxide. Then from here, we are going to use the ratio of the balanced equation, the coefficient. So we have 2:1. Then from here, we have to cross multiply. X multiplied by this, we have X. 2 multiplied by 4, we have 8 mole. So this is the second number of mole that I was referring to on the first method. The first number of moles, we have 3 mole, and then we need 8 moles, but we can see that we don't have enough, so it means that our sodium hydroxide is the limiting reagent. You can go ahead and verify that the next one is it's our excess reagent. So the coefficient is 2:1. Then we are going to put X here, since we are checking whether this is the limiting reagent. Then we have 3 number of moles. Then cross multiplying, we have 2x is equals to 3. Divide both sides by 2. Then x is equals to 1.5 mole. So you can see that the second number of mole, we have enough of it, because the first number of moles is 4. We need 1.5, so we have more than 1.5. So this is the excess reagent. Or another method which will make things clear, like I said, we have the first number of mole and the second number of mole. We can conclude from this by using this equation. Always when you take the first number of mole minus the second number of mole, if it happens that your answer becomes negative, if your answer is negative, you should know that that particular substance is the limiting reagent. Then if you take first number of mole minus the second number of mole, and then your answer becomes positive, you should know that it's the excess reagent. So let us look at this. 3 minus 8, we are going to get 3 minus 8, we are going to get -5. So you can see that the answer is negative. Then we go ahead and check this one. We have 4 minus 1.5. The answer is 2.5. So you can see that this one is positive, this one is negative. Therefore, this is the limiting reagent, this is the excess reagent. It's another way of determining the limiting reagent and the excess reagent. So in order for us to answer our next question, we are going to be needing the limiting reagent. The question says, what is the maximum number of moles of sodium carbonate can be formed? Now looking at the equation, we can see that sodium carbonate is the product. So in order to determine any product or the formation or the production of any product, we are going to be needing the limiting reagent, because we are going to perform mole ratio between the limiting reagent and the product, or let me say that desired product. So in this case, we are going to be using the mole ratio between the product. Remember that you're looking for the product, that is why we put it on the numerator level, over the limiting reagent, equals to the ratio of the product over the ratio of the limiting reagent. The ratio is the coefficients. So in this case, number of moles of sodium carbonate over number of mole of sodium hydroxide, it's equals to, we have 1:2. You can double check the balanced equation. So you can see that we have 2 and 1. Now in this case, we substitute by the number of moles, the first one, this one, the one that we have, not the one that we're checking, no, the one that we have. Don't make that mistake. So we have 3 here, it's equals to 1/2. Then solving this by multiplying by 3 both sides, sodium carbonate, it's equals to 3/2. Sodium carbonate is equals to 1.5 mole. So this is the number of moles of sodium carbonate produced. Now let us look at our options. You can see that the correct option is actually this one. Oh no, we are busy with question 10, which is this one. So it's option 2. There is a lesson video that covers all these concepts, so just make sure that you watch that lesson video. Now looking at question 11, how many moles of excess reagent remained unreacted? Now looking at our methods, if you can check here, this is the actual answer. In order to find the number of mole unreacted or left, we can see the number of moles of left, it's equals to the number of mole of total minus number of mole reacted. So this is the unreacted, this is reacted. The unreacted is the one that is left, the one that is in excess. This equation, it originally comes from the total number of mole, it's equals to the number of mole left plus number of mole reacted. Then making this the subject of the formula, we are going to have something like this. So if you can check our method here, this is the total number of mole total, the one that we have, and then this is the number of mole reacted, meaning that if I take this minus this, I'm going to have our number of mole left. Or we can quickly write it here. So we are going to take 4 minus 1.5, it will give us 2.5 mole. So this is the number of mole that is left, which is option 4. Option 4 is the correct option. Now we go to number 12. If the actual mass of sodium carbonate produced was 0.5 mole, what is the percentage yield of sodium? In order for us to calculate the percentage yield, we are going to be using this equation. It's actual yield divided by theoretical yield multiplied by 100. And you should know that always this equation, should it happen that you are confused whether theoretical yield is on the numerator level or the denominator level, you should know that it's always a small number or small magnitude divided by big magnitude multiplied by 100. So theoretical yield is the one that we calculated from this option. This is the theoretical yield. Theoretical yield is the production of the product, the maximum production of the product. This case that we found that it's 1.5. and then we are given the actual, which is 0.5. So you can see that 1.5 and 0.5, this is smaller than this. So if this is the actual, then this will be the theoretical. Or if it happens that you forget, you don't have to write this equation. You can simply substitute right away. You have 0.5 divided by 1.5 multiplied by 100. So let me quickly punch this on the calculator. It's 0.5 multiplied by 0.5 divided by 1.5 multiplied by 100. We get 33.33%. So this is the percentage yield. Looking at our option, this is the correct option, which is option 3. So in order for you to check whether you understood how to answer this, there is a worksheet, or let me say a set of questions that are within this lesson video. Just make sure you go through the questions to understand. Now that's it for this lesson video. This is Fahula SJ. Thank you very much.